Okay, so in 3.2, we are talking about average rate of change and instantaneous rate of change. So these are going to be words that actually show up in the question, okay? So average rate of change, this won't look any familiar because remember, it really is your slope. So y minus y over x minus x. They can also ask for it in a multiple choice question as the slope of a secant line, although usually it will say find the average rate of change, okay? Graphically, it's between 2 points. So you're finding this. Okay, it is the slope of a secant line. The secant runs through a curve. The other thing is going to be instantaneous rate of change. So instantaneous rate of change we've been doing, it is the derivative of the tangent line at a specific point. Okay, we are going to be doing motion in this unit, and so you're going to see average velocity and instantaneous velocity. Okay, so just kind of, I want to get you prepared for that. Slope of a tangent line, you have your line here and then your curve, and then slope of a tangent line, which is what you're really doing. So instantaneous rate of change is the same as tangent slope. They just call it something different for applications, basically. So graphing calculators will be allowed on some of the multiple choice questions, and you can usually tell by the answer choices. So I know you guys want to know, like, can we use a calculator? Can we not? And it's like, well, look at the function. If it's like E and the answers are all decimals or nothing, then you probably can. Like on my first example, okay? If you're not given any answer choices like this, well, that's just a power rule. So usually the answer is no. I want you to be able to do the derivative, plug in the points, and clean it up. It's not that long. So kind of look at the complexity of the question, okay? I mix them together from here on out because I want you to get more used to your calculator, but you probably are still only going to be able to use it about 5% of the time. We really won't be using them a lot until January, so have them ready. If you don't have a graphing calculator, please email me and we have some options, okay? All right, so pretzels. The number of pretzels in a tray could be modeled by this function. Notice it's a trig function, so make sure your calculator is in radians. I'm not going to bring up my graphing calculator just because it's a lot quicker for me to type it in myself. So it says when t equals 1 minute, find the average rate of change of pretzels over the next 30 seconds. So what we want is we really want to start at 1 and we want to go the next 30 seconds, which is a half a minute, and 1.5. Okay, so make sure they're in the same units. So I'm really looking for P of 1.5 minus P of 1 all over 1.5 minus 1. So I really am going to, I'll write my decimals here so you can double check your work, but you can type this all straight into your calculator. So I'm going to plug in 1.5 for T, and then I'm going to plug in 1 for T. So I'll go ahead and plug in 1.5. And because you are not done with the problem, I write all of the decimal places out. So then my answer, in case they were super close, which none of these are, but they might be, and I'll be able to distinguish that. If you are rounding before you're done with the problem and the answers are close, you might not be able to determine which one is the answer. Make sure you're using your pi button on your calculator. And then I'm going to type that in, and we're going to plug in 1. If you want help with the graphing calculator, please email me for a one-on-one Zoom, and I can do more help with you one-on-one. Okay? So remember, in calculus, the answer is 3 decimals minimum, except they just chose to have less, probably because there are less, but and I'm just typing that all straight in. So I got, and that's why. All right, and then that one matches up. Okay, so notice you see the words, they give you a function, and you see the answer choices. The label, because we are doing a slope, it is pretzels per minute. On free response, they might ask you to label it, and labels are always worth 1 point. Okay, so it's good to know. All right, we have a graph. It says water is placed in a teapot, brought to a boil. The graph of the water's temperature. So this is our temperature in Fahrenheit. Over what time period is the water's average rate of change the smallest? So what I'm looking for is the slope to be the smallest. So remember, slope is kind of like your steepness. So I want this to be the most flat. Okay. So from 0 to 1, I'm going to see if I can kind of eyeball it without actually doing. So that's 0 to 1 without doing the actual calculations. 1 to 2. Well, I already know that that is smaller than my pink. So I'm going to go ahead and cross that one out. We're going to kind of compare. I'll change colors. 2 to 5. So we start at 2 and we go to 5. And if I would do my, well, that's even flatter than my purple. So I know B is not true. So then let's get a different color. 3 to 5. So here's 3 to 5. And notice I'm not actually doing any math. That's flatter than my green. And then from 0 to 6, let's do red. So 0 to 6. Well, that's definitely steeper than my last line, which is blue. So without doing any calculation, this was like a 30-second question, okay? So don't always think you have to find the exact. Sometimes they just want you to compare it. So you need to know what you're comparing and how to compare it. So I knew slope, the flatter the line, the smaller the value, okay? Use that. Wouldn't be any work to show. Like, honestly, my graph shows me that I understand the problem. But for multiple choice on an AP test, you don't see work. All right, find the instantaneous rate of change. So that right to me, I'm telling you, you want to know that means take the derivative, okay? So our derivative should be pretty quick if we're not given a calculator. It's power rule. So 9t squared plus 1, and then that goes to 0. And then we want to plug in 2. It is really a good idea to get used to writing all your notation because it helps on the free response. But you guys are generally doing a pretty good pretty good job at that. What do we get? 4, 36, 37. So that would be my instantaneous rate of change. Okay. So something like my next problem, it says, oops, find the average rate of change. So then I know it's slope. So I'm looking for f of 3. And I always write my formula because this can be worth 1 point. Do you have to do this if this was a free response? No, but it's not a bad idea to get in the habit of it. Okay, you're kind of letting your reader, because it's an unknown teacher to you, know that you know what you're looking for. So we're going to plug in 3. And you can just do this work on the side. So I'm just going to label it because I like to label things. 27 plus 3 is 30. 30 minus 5, so 25. I plug in 1, so 3 plus 4, 4 minus 5 is negative 1, all over 2. And my average rate of change is 26 over 2, so 13. Okay. All right, my last one, this looks kind of complicated, huh? So f is a function, so we know f of 0 equals some unknown number, so it looks like they're introducing k's. F of 1 equals that, f of 2 equals that. If the average rate of change of f from 0 to 1 is the same as the average rate of change from 1 to 5, find k. So what we know is, well, let's find the average rate of change from, and I'll just label. You wouldn't have to do this for the reader. You'll do my second step. Average rate of change from 1 to x equals 5. Okay, so if we know that they're the same, that means that they're equal. So this is me in words. So let's find our average rate of change. So that means that f of 1 minus f of 0 all over 1 minus 0 is the same of f of 5 minus f of 1 all over 5 minus 1. Okay, so this definitely takes it to a higher level of difficulty. And it's going to take a little more time. So f of 1, so we know this is f of 1. So substitution. F of 0 is k all over 1 minus 0. And then f of 5, they tell us, minus f of 1. Remember, that needs to go in parentheses because we're subtracting, all over 5 minus 1. And so we want to solve this. It says, hey, find k. And since we have equations, we should be able to. So if I simplify the left, we get 1k plus 1. I'm going to distribute this, and I'm just going to kind of cheat. You can do this too because you're showing your work. So I get k squared. Let's see, 3k minus 2k is 1k. And then minus 1 is negative 6. And this is still all over 4. So if we want to solve this, remember you multiply both of these numbers by 4. I'm going to do it up here. So 4k plus 4, that's a plus, equals this. Because I see a k squared, you should be mentally thinking, hey, let's factor everything. So get everything to one side. So we're going to subtract 4k and subtract 4. So you want that equals 0. So k squared minus 3k minus 10. And this should be something that's factorable because I know we wouldn't be allowed a calculator. So I'm using AC method or guess and check or trinomials, however you were taught. The factors of 10 that add to give me 3 would be 5 and 2. If I add them together, a negative 5 and a positive 2 give me negative 3. That's how I know those are the factors. So then the zero product property says I can split both of those up and set them equal to 0. This is all review, so if you need more time, email me and I can do a Zoom with you to give you some more one-on-one help. Okay? So to find k, we don't have any restrictions because I don't have any more information in the problem. So we can't really eliminate anything because we don't know any domain restrictions. Like if this was a square root problem or a time problem, we're just given some general information. So I got negative 2 and 5. But that's why some of these say like 5 only, negative 2 only, because there could be a domain restriction if this was natural log or something like that. All right. We don't have any information about the original function, so we don't have any restrictions that we know of. All right, another one. So the velocity. So this is the velocity equation. We're going to learn later that that kind of means something else. Write an expression for the average rate of change of the velocity. So that's super important, from 2 seconds to 2 plus k seconds. And they always give this restriction because they want like your k number not to be equal to 0. Otherwise, it would just be 2 to 2. Okay, so that's what that really does mean. So we're really looking for the velocity of 2 plus k because I'm adding some unknown amount to it all over this. So we've got 2 plus k minus 2. All right, and so that really is our average rate of change. Okay. Whew. Well, this is multiple choice, so you could guess, but we are replacing 2 plus k. This is composition or function substitution everywhere we see the t in the original. So I'm going to show that down here. So I get 2 plus k squared plus we have 4, substitute 2 plus k, and we still have minus 5. That's all just this. Minus, since I subtract, I'm going to use parentheses when I plug in 2. So I'll just write it out. 2 squared plus 4 times 2 minus 5. And then my 2's will cross out, so it's all over k. It's the average rate of change. Now, you cannot just square each of these terms. Remember, that does mean 2 plus k times 2 plus k. And then all of this. I'm going to go ahead and distribute. So I get 8 plus 4k minus 5. And then let's clean that up. What's that? 4, 8 minus 5. So 4 plus 8 is 12. 12 minus 5 is 7. So minus 7. So this, if I multiply 4 plus 2k plus 2k plus k squared, and then we get plus 8 plus 4k minus 12. I just combine those together. Okay, so I get k squared what's that? 2 plus 2 is 4. 4 plus 4 is 8.